Hi, Kristen Atchison here, and we're going to be talking about independent groups and within subjects designs. Now, these are both types of experimental designs, and they also go by a couple other names that we'll talk about as we go through. Independent groups can also be called between subjects, and within subjects can also be called repeated measures designs. So again, independent groups, also known as between subjects or between groups, they're all the same thing and they all mean the same thing, just different textbooks will talk about them in different ways. And since we use kind of a myriad of text sources, we'll kind of use them all synonymously. Same thing with within groups design. They're also within subjects designs. This includes things like concurrent and repeated measures designs, and we'll specifically use repeated measures as interchangeable with within groups or within subjects designs. The question then becomes, which is better? Well, it really depends. There's some designs that really lend themselves very well to between subjects designs, and there's some designs that really, and research questions that really lend themselves to within groups. There's some things that you can't do between subjects. There's some things you can't do within subjects. It really kind of just depends on the particular research question that you're looking at. And so one of the skills that we're going to be working on is how to not only, we've talked about how to determine if it's an experimental design, but once you've decided that it is an experiment and that they've manipulated the independent variable and they've measured the dependent variable and they're looking at cause and effect, the next question is kind of how did they do that? How did they manipulate these? How did they manipulate the independent variable? And it's done in one of these two ways. It's either done as an independent group or between subjects, where different groups got different levels of the independent variable. Or it's done as a within group design where the same group got both levels of the independent variable. And we'll talk about this in more detail as we go on. So we're going to first start with between subjects or independent groups, and then we'll come back to within, and then we'll talk about them a little bit together at the end. So between subjects or independent groups designs have several advantages. One of which is they're really nice and clean and simple. You don't have to worry about the control group getting the experimental condition and having any kind of overlap between them, having those interact in any kind of way. You don't have to worry about that. There's no concerns about your participants getting bored or tired. You don't have to worry about any kind of experiences influencing subsequent performance because they've only done one thing. They're very, very simple. Again, this is what we kind of think about traditionally as when we think about an experiment where you have one group get nothing or the control condition, and you have a separate group of people get the experimental condition. Again, this is very, very simple. It's very easy to kind of wrap our heads around, and the statistics for them will be more simple as well because of this. The disadvantages of them are because we're looking at different groups of people, because we're looking at the differences between individual subjects, we have problems of individual differences. Your groups may not be the same. Your average age between your control group and your experimental group might be different. And if it's different enough, that could maybe be cause to say that, oh, well, maybe it's the difference in age that's contributing to this change in the dependent variable and not our manipulation of the independent variable. And we also need a lot more participants. If you have two groups of people, you need twice the participants than if you have one group of people. But again, individual differences are kind of our major problem that we have with between subjects design. And I'll kind of show you why this can be a problem. So again, we've got several sources of variability in a between subjects design. We can have differences between conditions, and this would be our effect of the independent variable on the dependent variable. So again, we're saying that there's variability is one of the things that we're measuring, right, to see how different these two groups are, and this is where we want them to be different. We want them to be different between our conditions, and we want that difference ideally to be because of our manipulation of the independent variable on the dependent variable, causing change on the dependent variable. We can also have sources of variability within the condition, and this is where those individual differences. We've got different people in each condition, and those people will differ from each other. Okay, so we're going to you have Joe and Sally and Sam in one condition, and you have John and Charlie and Suzanne in another condition, those are 6 different people. And those 3 people in condition A are going to be different than those 3 people in condition B. And that creates these individual differences. And then we have the problem of, okay, well, is the change that we see on the dependent variable because of our manipulation of the independent variable, or could it be because of these groups of people were different to begin with? So here's a little graph that's looking at results from a simulated experiment comparing 2 groups of participants. And these were selected from a population that was pretty homogeneous, okay? So there weren't many differences between people. And so we have a very, very small individual difference. When we do this, you can see that our control condition, the blue blocks, and our treatment condition, the white blocks, whatever change that we caused was a lot easier to see. Here's the exact same idea. It's again the simulated experiment comparing 2 conditions. However, this population has a lot of individual difference in it. This is a diverse group of people. And here you see that we don't see those same clusters of control findings versus treatment findings because there's a lot more variability in our data. There's a lot more variability in our data because of individual differences. And so this variability can be a confounding variable. It could show us, it could look like there's no effect here. And that could then cloud whether there really is an effect or not based on our manipulation of the independent variable. So individual differences can kind of hide that add variability in. And this is really our major problem with between subject designs. When we'll go and use within subject designs, one of the reasons that we're probably doing it is to control for individual differences. So we don't have to worry about this fact of individual differences. Now, all is not lost. There are ways that we can control individual differences in a between subjects design, and we'll talk about those as well. So again, the confounding variables in a between subjects design can come from the main one being individual differences, okay? So this is the number one confounding variable that we have to worry about. This is our number one risk for between subjects designs is individual differences. Again, all is not lost, and we can control this. And the way that we control this in between subjects design is through random assignment. Everybody has an equal shot of being in whichever group it is. We also have confounds from environmental variables. And so this is everything else, right? So these are all those extraneous variables that could become confounding variables. And so what we control those by is holding conditions constant and or balancing them depending on what they are. Okay, so if it's something that we can keep the same, we're going to keep it the same. That's ideal. If it's something that we can't keep the same, well, then we'll work with that. So if you're doing a study and you can't for some reason do it in the same room every time, well, then what you'll do is you'll balance that between the conditions. So condition A will get half the time in room A and half the time in room B. Condition B will get half the time in room A and half the time in room B. So that we have balanced that variability between both conditions. And that allows us to control for that and say, okay, well, any differences between the room aren't causing these changes on my dependent variable because they're in both groups. And if they are, they cancel each other out. Again, the number one thing that we really have to worry about are these individual differences, and the way that we're controlling that is random assignment. We'll talk about that in some more detail today, and we'll also talk about that some more detail in class as well. So these between subjects or independent groups design, what we have here is different individuals are participating in each condition of the experiment. There's no overlap of participants across condition. You have 3 people in the treatment and you have 3 people in the control. You have 25 people in treatment, you have 25 people in the control for a total of 50. There's no overlap of participants across conditions. So you get 1 score for each participant. So if you have 50 scores, it's because you have 50 participants. If you have 100 scores, it's because you have 100 participants. If you have 30 people participate in your study, you'll get 30 scores. And there are 3 main types of these that we're going to talk about, 2 of them in more detail, one of which is random groups designs. We'll also talk in detail about match groups design, and this will be both today and in our in-class portion. And then finally, natural groups designs. And these natural groups design we won't talk about as much. These are more our quasi-experimental designs. And this is where we have that kind of subject variable. We're comparing males versus females. We're comparing treatment a group with a diagnosis such as schizophrenia with a group of typical controls. So again, there's something natural about this group that we can't manipulate. We can't use random assignment for. There's no random assignment in a natural groups design, so it makes it a quasi-experimental design, even if other things are being manipulated. So here's a graphic of a random groups design, and I believe this is from a previous textbook and not your own. And what we have is we have a sample of people that have been selected from the population, okay? And in that sample, everybody has an equal shot of getting in one of the three groups. When we do this in class, we'll do this with the bag of randomization. We'll put everybody's name in a bag and we'll pull them out. Okay, we'll pull them out for each condition that people are going to be in. So everybody's got an equal shot of being in whichever conditions there are. So here we have group 1, group 2, and group 3. They're separate. We don't have any overlap between them. But again, everybody's got an equal shot of being in one of the three. These people are, again, randomly assigned to the conditions of the independent variable. If you have 2 conditions, you're going to have 2 groups of people. If you have 3 conditions, you're going to have 3 groups of people. And everybody has an equal shot of getting in each condition. These groups are equivalent on average before the independent variable manipulation. And the reason that we do random assignment is to make them equivalent on average before the independent variable manipulation. This is even more true as the more people you have in your study. So if you have 3 people in your study, you're going to be more likely to have these groups not be as equal on average than if you have 300 people in your study. So again, the number will contribute to this as well. This allows us to say that any differences between the groups on the measured dependent variable are caused by our independent variable because we've controlled for other conditions by holding them constant, and we've randomly assigned to create these equivalent groups. These equivalent groups, or these separate groups, must be created equally. And that's done through random assignment, okay? So everybody's got an equal shot of doing this. And again, it makes us, on average, these groups will be equal. And this, again, is even more true the larger your sample size. These groups must also be treated equally. We got to do the same things to both groups, except for our manipulation of the independent variable. Everything else needs to be either held constant or balanced. They need to be treated exactly equally between the 2 conditions. And we do this so that we eliminate all those alternative explanations. The only thing that could be causing this change in the dependent variable is our manipulation of the independent variable because these 2 groups were treated equally. In giving directions and things like that for studies, a lot of times those directions will be written out and the participant will read them and the experimental will read them to them as well. And that's so that they're getting the exact same rules every single time, and everybody's being treated equally within each group and between each group. And they also need to be composed of equivalent individuals. Again, this is going to be done through random assignment. Everybody's got an equal shot of getting into each group. So an additional independent group design is the match group design. So we were talking about random groups, and this is, again, ideal because random groups, everybody's got an equal shot. They're very separate groups. Another kind of design we have is a match group design. So random assignment and random groups designs really require these large samples to adequately balance them. And that's just has to do with the normal curve and probability and all that good thing. So think about flipping a coin, right? If you flip a coin 10 times, you may end up with 50-50, but you could equally end up with 70-10, right? 70-30, I mean. So you could, it's not necessarily that you're going to end up with this 50-50. Whereas if you flip a coin 1,000 times, you're going to be a lot closer to that 50-50. Okay, and this is, again, probability. So the larger your sample, the more likely you are to be able to balance those subject characteristics through random assignments. But sometimes you can't get a sample that big. Sometimes you just have a small sample. This can be especially true in studies where we're dealing with a diagnosis or things like that. That's going to be a lot smaller population to begin with. It's going to be a lot harder to get those people to participate, and these sorts of things. And so what we do in a match group design is we select one or two individual differences for matching. So if you're looking at a group of people that has, say, is on the autism spectrum, and let's say they're high-functioning autistic children, and you're wanting to compare them to a typical control group. Well, you want those people to be in your typical control group to be as similar to the people in your autistic group as possible, with the only main difference being their diagnoses. Now, again, this would be a natural groups design, but you can kind of control better for that based on matching. So you can find, okay, we're going to have them age matched. So we have a 17-year-old autistic child. I need a 17-year-old autistic male child. I need a 17-year-old male control. Matching. Another example of matching that we've done in class with our goldfish crackers, height, right? So we said, well, maybe height is somehow related to thirst, right? Maybe that's a measure of body mass, and so that's related to thirst, and so we're going to match by height. And so again, we have random assignment within that pair. Okay, so we took our two tallest people and we said, okay, well, they're a pair, and within that pair, this person's going to be in the pretzel group and this one's going to be in the cheese group, okay? So we matched based on those. We could have done it with the three groups as well. This person, the top three height, the tallest three people, this person's going to be in the pretzel, this one's going to be in the cheese, this one's going to be in the original goldfish group from our example in class. Again, they're selecting one or two individual differences for matching. When we're doing these between subjects designs, and we'll talk more about these random groups and match group designs in our in-class portion as well. We'll talk about them in a little bit more detail. Our statistics for our between subjects designs, when you have two mean groups, we're going to look at mean differences, okay? And we're going to calculate the means for each group, and we're going to say, are these means different enough to say that our independent variable caused change on our dependent variable? And the way that we're going to do that is the t-test for independent groups. Again, we talked about this a little bit with our goldfish cracker experiment. This two groups allows you to really maximize the differences, okay? So that's why we choose a treatment group and a control group. We're really maximizing the differences. We have all or none, right? So this two group really allows us to kind of choose these opposite extremes and really maximize the difference between them. This is really simple, but we're not getting detailed information. We have the effect of nothing and we have the effect of something, but we don't know how much of this something really causes the effect with these two group mean differences. When we have more than two groups, we're still calculating the means for each group, and we're doing this in an analysis of variance. We can't say, okay, well, we have three means. How are these different? We can't just take the difference between three numbers and get an equivalent of how they're different, because they'll start to cancel each other out. So we're going to do this through analysis of variance, which is ANOVA. And again, we mentioned this a little bit earlier. And these are really helpful because when we have these three groups, it's stronger evidence for cause and effect. So say you have your treatment group, your control group, and the treatment group gets 100 milligrams and your control group gets 0 milligrams. We have those two opposite extremes. Well, say you add a third group and you add 50 milligrams, okay? And you see half the effect with 50 milligrams that you saw with 100 milligrams. You're allowed to, this is stronger evidence for cause and effect because we gave you half as much and we saw half an effect. We gave you twice as much and we saw twice the effect. Again, you're getting a stronger evidence here. Now we can really dilute these. We can pull these out too much and have too many group and really lose our differences. If we do 5, 10, 15, 20, 25, 30 milligrams and kind of go all the way up to 100, Well, you're probably not going to see big differences between your 0 and your 5, and your 5 and your 10, and your 10 and your 15. And so this really, we lose some of that differences, so we can kind of take this to the extreme too. And so that's why you'll typically see kind of 3, 4, maybe sometimes 5 conditions, but they don't typically go too much higher than that because you really start to lose whatever effect there is. So for between subjects designs, and this will be helpful to look back on when we get to statistics, when you have 2 conditions in a between subjects experimental design, you're going to be doing a t-test for independent groups. When you have 2 or more conditions, so 3 conditions, you're going to be using a one-way ANOVA. Again, the reason that Georgia State has designed their courses the way that they have is because your research methods dictate what statistical tests you're going to be using. And so the way I've structured this class is that we learn the research methods, we understand the research methods, and then we do the statistics. Because again, the research methods are what decide our statistical test. We have to be thinking about these things as we go, okay? And so we look at the method to determine what kind of test we do. So again, with a between subjects design, these are going to be the kinds of tests that we're going to be using. This is only true for numerical data. There are other examples of other kinds of data that we can't use with a between subject design for a t-test or an ANOVA, just based on the kind of data that they are. So within subjects designs or repeated measures, and again, these are types of experimental design, all the designs that we're going to be talking about primarily in 3530, again, are types of experimental designs. So when I'm asking you on an exam or something like that, what kind of research design is this? They're all kind of experimental design, so you can put experimental, but I'm gonna want you to put a within subjects experimental design or a between subjects experimental design, that you can show me that these are different kinds of, that you can identify these different kinds of designs. Again, this is really, really important because it helps you decide what statistical tests you're going to need to do. So we don't have a cumulative exam in this class, but our content is all cumulative. You have to understand these different kinds of designs to be able to determine what kind of statistical tests to do. So we'll continue to ask you throughout the semester, what kind of research design is this? And then I'm asking you to tell me within subjects experimental design, between subjects experimental design. When we get to it, factorial experimental design, these sorts of things. So within group design is different, clearly, than a between subject design, and in that the entire experiment is happening within one individual. So each individual participates in each condition of the experiment. They're both in the control group and the experimental group. They're in both. And they complete the dependent variable for each condition. So if you have one dependent variable and 2 levels of your independent variable, I'm going to have 2 scores for each person, okay? So I have 15 people in my study. I have 2 levels of the independent variable. I end up with 30 scores because each person gives me both a treatment and control condition score on the dependent variable, and 2 times the 15 people I have is 30. So I end up with 30 scores. This is also called a within subjects design or a repeated measures design. And the reason we do this is because the entire experiment is conducted within each individual, within each participant, okay? So if you have 3 levels of the independent variable, all 3 of those levels will be given to one individual person. We'll get all of that. It's also called repeated measures because we're repeatedly measuring them, right? We measured them in the control condition. We measured them in the treatment condition. We repeatedly measured them. A graphic, what that looks like is we take that sample of participants and they go through the treatment. Condition 1, they go through the treatment. The same people go through the treatment condition 2, and they go through the treatment condition 3. They go through all 3 of these. So we'll end up with 3 scores of people, 3 scores for each one of these people, which will give us, and we'll still compare treatment group 1 to treatment group 2 to treatment group 3. We'll still compare those 3 groups, but we'll have the same people in every single condition. The benefits of these repeated measures designs is we don't have to worry about individual differences. This is kind of one of the reasons that we do it. And we don't have to worry about individual differences because we have the same people in each condition. Joe and Sally and John are in the treatment condition, and Joe and Sally and John are in the control condition. They're in both. And so we don't have to worry about these individual differences between groups because there are no individual differences. Any variability that's due to individual differences is eliminated. It's not there because we have the same people in each group. When we get to the statistics portion, we'll actually eliminate those individual differences by subtracting them out. We'll say how much individual difference is here, let's just pull it out, okay? And so we'll eliminate that as well because there's not individual differences in a within subject design. They're also really nice because you need fewer people. So the majority of my infant work was done as a repeated measures design or within subjects design. Infants are hard to come by. Infants are hard to work with. And so every baby that came, they were in the control, they saw control test trials and they saw experimental test trials so that we really had fewer participants. They're also convenient and efficient. Again, I got 2 data points out of 1 kid. I got twice the data out of 1 person, which is very convenient and very efficient. They're also more sensitive, and we'll talk a little bit about sensitivity in a second. Sensitivity is the ability to detect a change in the independent variable when it's there. And we'll talk about why they're more sensitive as well. So again, this advantages of a within subjects design. Participants are equivalent because you've got the same people in each group. We don't have to worry about individual differences. They're also acting as their own controls. And for my infant work, that was really, really helpful. Infants kind of are actually a very variable group in terms of looking and things like that. And that's what we were measuring, is looking time. Some babies just look at things very short, and some babies will look at things as long as you let them. And so we had these differences. And so by having every baby act as their own control, we could really look at how these effects were happening. So again, because they are their own control, we're eliminating the issues of individual difference. It's just not there. So here's an example from your textbook where we have the independent groups designs in the light blue, and we have the within groups designs in the dark blue. And what you see here is that in the independent groups designs, we have 12 people in condition 1. We have 12 different people, so participants 13 through 24 in condition 2, and we have another 12 people in condition 3, participants 25 through 36. So we end up with 36 people in the independent groups design. Say you need 12 people for your within groups design as well. You have 12 people in condition 1. You have the exact same 12 people in condition 2. See, participants 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are the same people that are in condition 2, and they're the same people that are in condition 3. So we end up with only 12 participants here in a within groups design where we had 36 participants here in the independent groups design. So again, that light blue is the independent groups, the dark blue is the within groups. And we're really eliminating individual differences by using this within subjects design because everybody's acting as their own control. If this is a control condition and you give 50 milligrams here and you give 100 milligrams here and you do it over a course of several days, so you could see maybe the effect of, maybe it's caffeine, the effect of caffeine on an individual. Caffeine gets out of your system very quickly, and so it's something you could do over multiple days. You could see the effect of caffeine in these 3 subsequent testings. This gives researchers more power to notice differences between conditions. This is because they're more sensitive. And we'll talk about this power, sensitivity, kind of relationship a little bit more later. And there is a video kind of on YouTube that talks about the relationship of power mathematically as is set by alpha and beta. So it's kind of some of a review from 3510. So that might be helpful to look at. Again, the other advantage of within group design, we just need less people. We need 12 people for each condition. That was 36 people in our between subjects design, where it's only 12 people in our independent groups design. So this sensitivity is again related to power. And a sensitive experiment is an experiment that can detect the effect of the independent variable. So if the independent variable is causing change, if you've got a sensitive enough experiment, you're going to be able to say the independent variable caused change, even if that effect is very, very small. So even if it's a really tiny effect, even if it only goes up just a little bit, if you have a sensitive experiment, you're going to be able to detect that. Within groups designs are more sensitive than these independent groups designs. The reason that they're more sensitive is because we've reduced the error variation. By pulling out that variability due to individual differences, by eliminating that, we've cut our variation. We've cut it down. This is because the same people are participating in each condition. So again, my example from the infants. Sometimes you'd have babies that would look at a control test trial for 10 seconds and an experimental test trial for 20 seconds. They doubled their time, right? But it only went up 10 seconds. Where you had another baby that would look at a control test trial for 30 seconds and look at the experimental test trial for 60 seconds. They both doubled their looking time, but it looks very different numerically between the two. One of them looks like they have a 30-point effect, and the other one looks like they have a 10-point effect. So by comparing each child to themselves, I just look at the kind of the rate of increase instead of just looking at the increase itself, the numbers themselves by themselves. So again, this variability due to individual differences is eliminated. And because we've eliminated this, all we have left is the variability due to chance, right? The variability due to these other kinds of things. So think back when we were talking about between subjects at the beginning of this lecture, we said that you could have variability due to individual differences, and you could have variability due to these environmental factors. And within subject design, we don't have variability due to individual differences. It's gone. So the only variability that we're left with is due to environmental characteristics, something about the environment that can just cause us to perform differently here or there. Okay? A variation due to chance. And so we have a more similar kind of group. And just like we saw with those slides at the beginning, that makes it easier to see the differences. Clearly, there's disadvantages to within groups designs too. They're not perfect either. One problem that we have with this is order effects, and we'll talk about these in a lot more detail. Order effects is when we're saying, okay, well, you're getting the conditions, all of them. Well, is there something about being first that just changes something? Is there something about being last that just changes something? Think back to your goldfish crackers, right? The third cracker, didn't matter what that cracker was, just made you thirstier, right? And so again, the solution that we'll do for this is counterbalancing. And we'll spend a lot more time talking about counterbalancing when we come to class. They might not be practical or possible, right? So if you're giving drugs, if you're doing a drug trial, okay, you can't have, say you're doing a drug trial for schizophrenia, okay? You can't have both being in the control group and getting a placebo and being in the experimental group and getting the medication. You can't do that because to be able to see the outcomes of these medications, you need to do them over long periods of time. And these medications typically stay in your system for long periods of time and take a while to kind of start to build up as well. So again, it may not be practical or possible to do this within subject design. And experiencing all the levels of the independent variable can really change the way the participants act. Even knowing just what the other levels are can change the way the participants act. And this is called demand characteristics. So the participants figure out the hypothesis. The more they know about the study, the more they're going to start to figure out the hypothesis. So an example of participants figuring out a hypothesis is if you think back to the Stanford prison study, right, where the college students were assigned to either be prisoners or guards. They go back and they interview these adults now that were in this study, and they said, "Oh, well, we thought this was a study about this, and so we did this." They thought what the hypothesis was, and so they acted accordingly to that. So again, the major disadvantage of a repeated measures designs are these order effects. And these are time-related factors. So they have to do with what was first, what was second, what was last, what time order that these were done in. People change as they're tested repeatedly. They could improve, they might get better, they might figure it out, or they could decline, right? They could get worse. And again, they can improve, they can decline, they can become bored or tired. When we moved to California, my daughter was, I think she was about 7 months old, and clearly I'm an infant researcher. I'm a big infant researcher nerd, and I was in a new area. We were by Berkeley. There was all this really interesting child development work going on, stuff with infants, and so I decided that I was going to be a research tourist, okay? And so I signed my daughter up for every study that she could do because it was really fun for me. Like, we had just gotten there. I was just learning the place. It let me kind of go see things. I didn't have a position I was teaching at yet. It was really, really interesting for me. And one of the studies that we looked at, that we were involved in, was about motor development. And every couple of weeks, they would send me a survey about her motor development and where she was on these sorts of things. And the questions were the same every single time. You just had to write down what she did at what different times. So say she crawled at 7 months and I had to write the date. Well, the next time they would ask me again when she crawled, and I needed to say 7 months and put the same date. The problem is that I took this thing so many times that I thought I knew all the questions really well. And so I would go through and I would answer these things really, really quickly. And I thought I was doing a good job until at the end of the study they called and they were like, so there were some differences in the data that you entered between different things. And I was like, oh, really? And so they were like, can you clarify the dates that she did these various things? And I actually had to have them, they were like, can you check in her baby book? And well, we had just moved to California. We weren't even in our house yet. We were still shopping for a house. So I said, can you send me what you have? And I will go back and try and figure out what's right. And so I had to go back and look at pictures and Facebook and things like that to figure out when she crawled and when she scooted and all these different things to really line up my date. I thought, because I had taken this quiz so many times, that I knew it. And so I thought that I didn't have to read these questions in the same level of detail. My performance declined over time, okay? I was repeatedly measured and my performance declined. Order effects become a potential confounding variable if not controlled. So then the problem is if you always have your treatment condition followed by your control condition, then we don't know if the change to your treatment condition and the difference between your treatment condition and your control condition on the dependent variable has to do with the fact that the treatment condition really worked or that the treatment condition was second. Is it just being second that made the difference? Just like the crackers, right? It didn't matter what kind of cracker you had third. The third cracker just made you thirstier, okay? So it wasn't about the kind, it was about the cracker itself. That order becomes a potential confounding variable. And then we can't say, well, it was our independent variable that caused a change in our dependent variable, because what it really might be is just the order. It becomes an alternative explanation. So these practice effects must be balanced or averaged across conditions. And we do this through counterbalancing. And again, we did this a little bit in class with the crackers. We counterbalance the order to distribute these practice effects equally. And again, we'll continue to talk about this in class as well. So half of the participants do condition A and half of the participants do condition B and then B. Whereas the other half of participants do B and then A. So half the people got pretzel, then cheese, and then the other half of the people got cheese and then pretzels. This is done through random assignment. Being assigned to which order is done randomly. Then conditions A and B had equivalent practice effects. So it didn't, both cheddar and pretzel got to be the second cracker. They both got to be second. We don't eliminate these practice effects. The second cracker still made you thirstier, but we've averaged them across the conditions of the experiment so that they're spread out. So they essentially will cancel each other out. So the fact that the second cracker just always made you thirstier is in both conditions. So any difference then that we see between the conditions, we can still say is due to our independent variable because we see those practice effects in both conditions. And again, we'll continue to talk about these. An example, outside of our terribly designed cracker experiment, suppose a researcher compares two study methods, okay, A and B. Condition A, participants are using a highlighter to mark key points when they're reading, and then they take a test on the material. Condition B, participants read the text, then they make up sample test questions and answers to take and then take the test on the material. So suppose we find out that all participants, suppose everybody does A and then B. So everybody reads the text and highlights, takes the test, and then everybody goes and makes sample questions, reads the text, makes sample questions, and then takes a test. Results indicate that people did better in A than B. Can we say with internal validity, without any alternative explanations, that marking the text with the highlighter was better than writing sample questions? It's really impossible to know because we've confounded it with the order of presentation. We've allowed something else to vary with our independent variable. This was affected by practice effects. Maybe people just got bored. Maybe reading the second thing and reading it a second time and making questions and taking the test again. They were just bored by the time they got there, or tired. That may account for the poor condition in condition B and not really have anything to do with the two study techniques. So also with our highlighting versus writing questions, suppose we got the exact opposite results. So we still have all the participants doing A and then B, and the results indicate that people actually did better in B than A. Can we say that B is better than A? Again, it's still impossible to know because we've still confounded the independent variable with the order of participation. Here what we have is carryover effects, okay? Here maybe it's just studying the material in two ways really improved performance. So by the second time you took that test, you were just better because you've done a better job of studying. Again, we don't say then necessarily that writing sample test questions is better because it may just be that you've done it twice. We have carryover effects. So we really need to counterbalance these. We need to create alternate orders so that we don't have these problems. And again, we'll talk more about counterbalancing and have half the participants get A then B, and the other half of the participants get B then A. We'll talk about more of that in class, kind of how we do that, the different ways that we can do that, and how that changes depending on the individual nature of our research question and our measurements. So again, because the research methods dictate the statistics, there's some different things. We still have some similarities to between groups designs. If it's two conditions, it's still a two test. If it's two or more conditions, it's still an ANOVA. The difference is now we're using the repeated measures versions of these tests, okay? So instead of using a t-test for independent groups, because we're doing a within groups design, we'll use a t-test for repeated measures. Instead of using an ANOVA, a one-way ANOVA for between groups, we'll use an ANOVA for repeated measures. So we're just using the repeated measures of these tests. And basically what these two tests do differently than they did in between measures is that we have to remove the individual difference. We have to come up with a way to pull those differences out, okay? The fact that John is different than Sue is not a problem within subject design because both John and Sue are in both conditions. Whereas John and Sue being different when John's in the treatment condition and in between groups and Sue's in the control condition and in between groups, that is a problem. So these statistical analyses will allow us to quantify how much individual differences there is and pull them out so that all we're left really is with the effect. So here's kind of a complete chart here where we have, again, two conditions. We have a within subjects repeated measures t-test. For independent groups, that's an independent t-test. For two or more conditions, we have the repeated measures ANOVA, and for two or more conditions with an independent group, we have the one-way ANOVA. This is a really helpful table, and I believe I have it presented other ways, and I will make sure that this table itself is included in the lecture outline so that you can see it, because this will be helpful for you when we get to that statistics portion of the class, and you really are required to figure out, okay, well, this is the design, so what statistical test do I do? This table, however, really only works for numerical data, like I said. So with non-numerical scores, we can't do a T or an F test. So nominal data, if we're looking at the difference between males and females, gender, academic major, so MF, well, we can't put M and F and calculate a mean male, female. We can calculate a mean on a dependent variable for male and female, but not if you're just saying male or female. Academic majors, freshmen, sophomore, junior, seniors, unless we're getting some sort of numeric data on those different groups and comparing the groups, if the data itself is just the nominal data, we can't use it. Same thing for occupation. Ordinal data we can also not use with T or Fs, so college classes we can't use with that. Birth order we can't use with that. Performance, high, medium, low, we can't use with that. So none of those really will work. So we really only can use the numerical scores, sometimes ratio if it's done right. So kind of a summary here, we have are starting to really compare these two designs. Both between subjects and within subjects are both types of experimental designs. So they're just different ways to conduct an experiment. They're different ways to ask an experimental question. They're different ways to ask a question about cause and effect. Really, these differences come into the independent variable and how the independent variable is manipulated. Within subject design, every participant gets every level of the independent variable. Where between subjects design, each participant only gets one condition of the independent variable. They only get one level of the independent variable. So we'll get multiple scores for one person within subject design, and we'll only get one score for our participant in a between subjects design. The other thing that they really differ on is what we balance or average across conditions, okay? And within subject design, we're balancing practice effects. We're doing that through counterbalancing that, again, we'll talk about in more detail in the next lecture. And in between subject design, we're also balancing things. We're also trying to average something across conditions, but here what we're doing is the individual difference variables, those subject variables, those individual differences. And we do this by random assignment, which we'll also talk about in more detail in the next lecture. So this is kind of just gets us set up to really talk about all these topics in more detail. So think back to what we did with our goldfish crackers, and kind of think forward to what we're going to do in talking about these in more detail. Thanks, and see you in class.